Hello and welcome. Let's talk about event-driven application development with Azure Functions and Logic Apps. In this session, we'll talk about just what is event-driven application development. We'll look at a demo that best showcases the advantages of event-driven applications, on how it can reduce development time and help you to be faster to market. After the demo, we'll recap on the technologies that was used in building the demo and see what are some of the new features we released. And lastly, we'll talk about what's next and how you can get involved. So without further ado, let's get started. The first question we have to answer is just what is event-driven application development? It is about reacting to changes, or events, as the name implies. We wanted to process these changes or events in real time or in an asynchronous fashion. And because events load may vary over time, we also want our solution to be flexible and scale according to load. It used to be complex to implement event-driven applications because of the multiple components and services involved. It is error-prone when it comes to handling these events, and it can be difficult to extend or scale to solve more problems and new scenarios. But with the power of Azure Event Grid and all the integrations from different Azure services emitting system events, the wide choice of event handlers such as Azure Function and Logic Apps, building event-driven application is now easier than ever. Event-driven application can be easy to develop, responds to things as it happens in real time or asynchronously, provide flexible and low-cost options for you to run, and most importantly, allow you to be faster to market. In this demo, we'll be building a disease contact tracing application. When a new case of infectious disease is recorded, it will identify a person who may have come in close contact with that new case, send them a notification, and assist them with scheduling an appointment to come in for testing. So let's take a look at the architectural diagram of the solution we'll be building together. Here on the left, we have a Cosmos database with 3 collections: case, person, and reservation. Upon a new case being added to the case collection, Cosmos DB will trigger an Azure function using change feed. Azure function will look at the zip code of that new case and query the person collection to find everyone sharing the same zip code using Cosmos DB input bind. Once identified, it will send a text message using Azure Communication Service, utilizing API connection to notify those people who may have the possible exposure to this new case. Users can then reply to the message, requesting detail on how to get tested. The reply would go back to Azure Communication Service, and it will raise a system topic through Event Grid. The event is being subscribed by a Logic App workflow. The workflow will query the reservation collection from Cosmos DB using connector, and then reply with the next available appointment time to the recipient. So as you can see here, we're building an end-to-end event-driven solution that involves multiple services. We need it not only be reliable, functioning in real time, but most importantly, it has to be fast to market from experience that we have all become too familiar with. So let's get started and build that solution together. For the purpose of this demo, I have the Cosmos DB and 3 collections already created. In Azure Portal, we made it really easy for you to add a function that will be triggered by change feed from a collection. Simply go to Add Azure Function and choose the container, function app, function, and language you want to write to handle that event. Alternatively, you can also do this in VS Code, and let me show you how. Here in VS Code, I have a local function app project already created, so I'm going to go ahead and add a new function to it. We use the Cosmos DB trigger, We'll call this new function on new cases. We'll use the connection string that I have already defined in my local settings file. The data we'll monitor will come from DB database and case collection. We can skip the rest of the parameters. And just like that, it created a function for me that will be triggered whenever a new case is added to my case collection. Now, before we write any more code, let's test that really quick. While that is running, I will switch to the databases extension and add a new case to my cases collection. I will let the extension generate a GUID as the ID, and it will specify the zip code here. Looks like my function is up and running locally, so I'm going to save the new document. And in just a few seconds, as you can see from the terminal, my function app have detected a new document being added to my Cosmos database. That's great. So now let's write some more code. The next thing I want to do is to be able to query the person collection. To do that, I will bring up the command bar and add a new binding to my function. We'll add it to the onNewCases function. It will be an input binding from Cosmos DB. We'll call it person. It will come from DB database and person collection. We'll use the same connection string like before. And we can skip the rest of the parameters. Now that we have a new input binding, as you see defined here, I can go to my TypeScript file and start interacting with that. And the first thing I will do is to declare that my function takes another input, a person, and is of type array. Now remember, the cases, which is called documents here, is also an array. So we'll do a for each loop on it. And inside, we want to filter the person array to those that matches the zip code of the cases. All right, let's test that again. And just like that, you can see the filtered array only contains person with the same zip code. That's great. Now the next thing I want to do is to send a text message to those people who have come in contact with this new case. And I will use Azure Communication Service to do that. But rather than using their APIs and SDKs directly, I want to use API connection to do it. If you're familiar with the API connection, you know that before this day, API connection has only been available to Logic App. But today, we're announcing the private preview of ability to use API connections inside Azure Function. But let me show you how it works right now. I will start by creating a new API connection. We'll choose a resource group, and then we'll choose Azure Communication Service as the connector. We'll call it ACS connection. Once the connection is created, I can provide the connection string, which I already have in my clipboard. We can verify from the extension that the connection has been created and is in the connected state. The last thing I have to do is to generate a connection string so my function code can invoke that API connection. Now I can go back to my local function app project and save that connection string here. Let's go back to my TypeScript code and write some code to send that text message. I will start by importing some class that I need in order to interact with the connector. Next, I will initialize an object that I can use, referencing the connection string I just created. Next, we construct the text message body and call send SMS to send a text message. The last thing I have to do is to get a list of phone numbers from a list of possible contacts. We can do that pretty easily with the map function here. Once done, we'll use that as the input. All right, let's test that again. And this time, if everything works as planned, I should be getting a text message from Azure Communication Service once I inserted that new document. Looks like it worked. Next, what I want to do is to create an event grid subscription for my Logic app so that it will be triggered whenever a new text reply is received by Azure Communication Service. Here you can see I have a Logic app inside VS Code, and it is the brand new Logic app running on the new containerized runtime so that I'm able to develop my Logic app locally, just like I was able to do with functions a moment ago. What I'm going to do here is to copy the request endpoint for my Logic app. And here, inside Azure Portal, I will create an event subscription for my Azure Communication Service resource. We'll give it a name. And it will select the event type being SMS received. The endpoint type will be a webhook. And the endpoint will be the request URL that we just copied. Now the only thing I have to do is to change my localhost to a turned endpoint so that I can bring the traffic back onto my machine. Let's create that event subscription and test it out in VS Code. Here in VS Code, I have a local Logic app project already created. Now this is the new Logic app running on the rehostable and containerized runtime, which allows me to develop and debug my workflows locally, just like I was able to do with Azure Functions. So now, let's start building our workflow. My workflow will start with a request trigger, which will be called by the event grid subscription we just created. The first thing I will add is a condition. We ask users to reply 1 if they want to get more information about appointment, so that is what we will be checking. I will choose message and compare that to value 1. If the condition evaluated to true, that means user want to get more information about how to schedule an appointment. We'll use the Cosmos DB connector to query the reservation collection to get the next available appointment time. We'll use the query document action and select DB as the database, reservation as the collection, and we'll write a simple query to basically select
every single document from that collection. After the Cosmos DB action, we'll use the Azure Communication Service connector to send a reply back to the user with the information we just retrieved from the database. Now, what's cool about this is I'm using the exact same ACS-con connection object that I created while writing my function code. So I'm able to reuse that API connection resource across multiple services within Azure. For this send SMS action, we'll use to as the phone number we'll be replying from, and we'll use the from phone number to reply back. That's the user's phone number. And in the message, we'll say the next available appointment time is, and then referencing the document object that we just got from Cosmos DB. So let's save. Now you will also notice that we have a brand new workflow designer that I used throughout my authoring experience. In this new design, we're separating the canvas, which is used for rendering a workflow graph and action dependencies, apart from the panel, which is used for configuring inputs. This is based on hundreds of hours of user research, and we think the new design will dramatically improve your experience working with workflows. This new designer will be made available together with the public preview of the new Logic App runtime. So please give it a try and let us know your feedback. Now, let's start running my Logic App locally and test it out. While the process is starting up, I'm going to switch back to my messaging app and simply type 1 to the message that I received and hit enter to reply. The event will then be turned back to my local machine and processed by the Logic App runtime. We'll query the Cosmos DB connector to get a list of reservations and then the ACS connector to reply. And in just a few seconds, I should be getting a text message back from Azure Communication Service with the next available appointment time.
All right, I hope you liked the demo. And let's recap. In just a few minutes, we built a disease contact tracing and notification solution. We used technologies such as Azure Logic Apps, functions, Cosmos DB, Azure Communication Service, and EventDriven. The solution we built is low-cost, real-time, but most importantly, we're able to deliver it fast to market. So now let's drill a little bit deeper into each and every single service that we talked about and understand what they are good for and what is new. Let's start with Azure Function. Azure Function is an event-driven serverless compute platform. The idea is to let you focus on writing the code and leave running it to the service. Use your choice of languages, select from C#, PowerShell, Python, JavaScript, TypeScript, and/or Java, and run it on Azure or on the edge with containers or Kubernetes. As for what's new, there is now a configuration hook for C# function. You can also now generate functions based on an open API stack or based on an API management resource. With durable functions, you can now write PowerShell and Python code for long-running and orchestrated functions. And lastly, improvements on static web app include Blazor static app, .NET Core, and Python functions. Next is Logic Apps. Logic App is an event-driven serverless workflow offered by Azure, and it has continuously been placed in the Gartner's Magic Quadrant. The visual designer allows you to build complex workflows with ease, utilizing more than 300 connectors provided out of the box. From Azure ones like Event Grid, Service Bus, SQL Azure, Active Directories, to Microsoft services such as Dynamic and Office, to third-party services such as SAP and Dropbox. It works great with Azure Functions as well, So you can use functions and logic apps together to solve your business problems, like you saw in the demo a moment ago. And we're continuously making it better. More recently, by making API connections available to functions. For customers needing to handle B2B and EDI workload, Logic App can also support that with integration account. As to what's new in Logic Apps, you just saw that Logic App now runs on containerized and rehostable runtime, capable of being run on functions, app service, Docker, Azure Arc, and Kubernetes, or locally. We introduced a new type of workload called stateless workload for low latency and high performance type of scenarios. With the new runtime, you can easily connect to your line of business applications using virtual network, private endpoints, and have data flow into App Insights. We have a new designer that makes authoring workflows even easier than before, and more improvements to be expected throughout the rest of this year. For DevOps, you can now develop and debug your Logic apps locally using VS Code, and then deploy it using GitHub Actions or Azure DevOps. Cosmos DB is a fully managed NoSQL database offering. It supports a wide range of APIs to fit your need, from SQL to Mongo, Cassandra, and so on. To run it, you can go with the provisioned capacity model, or alternatively, use serverless model that is now available in preview. As for what's new, there is the public preview of the serverless SKU I just mentioned and used in the demo, which supports core APIs, as well as Cosmos DB's MongoDB API for Azure Synapse Link. Now customers can write Spark queries for MongoDB or even T-SQL queries over MongoDB data. Features coming soon, among other things, is all API support for the serverless tier, including Mongo and Cassandra. Azure Communication Service helps you to build rich communication experiences. It opens up a whole realm of opportunities. Imagine taking the same chat, voice, and video capabilities and making these rich communication experiences available in any digital experience tailored to your specific scenarios and audience. Equally more important, you will be building these rich experiences with the same secure platform used by Microsoft Teams, trusted by 75 million active users. Azure Event Grid offers you reliable event delivery at massive scale, support both ingestion and push-style distribution of discrete events, with simple or complex subscription filters. We're now introducing CNCF Cloud Event 1.0 standard support and enhanced endpoint abuse protection. It has multi-tenancy support for SaaS applications, as well as a catalog of event sources and sinks. And lastly, let's talk about what's next and how you can get involved. On this Thursday, September the 24th at 10 a.m. Pacific time, Logic App team will be hosting a Logic App Live session to showcase all the new features and to answer your questions. So make sure to tune in at aka.ms/LA Live. And there will be an MS Create serverless session on September the 30th from 8 to noon Pacific time. Make sure to go to aka.ms/create serverless to sign up. And we can't wait for you to try out our new releases. There's the Logic App new containerized runtime and the new design. There's Azure Communication Service and the Cosmos DB serverless tier. And stay connected with us. You can find us on Twitter at LogicApps.io and Azure Functions. Thank you very much for watching and have a nice day.